Hi, everyone. So what I'm going to take you through here is the solutions to the solutions quiz. Basically, I'm going to walk you through the quiz that I assigned on Monday, and I'm hoping that by doing this, I'm going to kind of help some of you with areas where you had some difficulties. So one thing right off the bat that I'll tell you is I've got in front of me is I've got my periodic table in front for when I need to calculate, molar masses and things. I also have my solubility guidelines in front of me, sitting right here in front of me. And I've got my hub that has all my formulas on it. So I've got these two sitting in front of me as I sit down to do the quiz. So here we go. The other thing that I've done in preparation for this is I've went into the notes. So we've done 4 lessons so far in the solutions unit, and I've gone into those notes and just took pictures of the sections that I was hoping you would use to answer the questions. So you'll see that that's also on these slides. Okay, so here we go. Question number 1 says, which of the following factors does not impact the rate at which a solid dissolves? Or in other words, how fast something dissolves. Now, right up in the top corner here, I'll just indicate this to you. I've put down here what percentage of you got this question correct. So 93% of you that tried the quiz got this question correct. So this was obviously a pretty straightforward one. And sure enough, here's the note we took on it. It said the note was what determines how fast a substance dissolves, or the rate. And there were 4 things: the temperature, the agitation, the surface area, and the amount of solute already dissolved. And so here you can see that I've got stirring, which is agitation, temperature, then the color of the solvent, and the size of the particles of the surface area. So clearly the correct answer for this one was the color. The color doesn't, which of these does not impact? Well, the color does not impact. If it's a blue solvent or if it's a clear solvent, the color doesn't impact it. Okay, so that was that first one. Okay, number 2. Number 2 says 0.25 moles of potassium nitrate is added to 175 milliliters of water. What is the molar concentration of the potassium nitrate? Now, only 47% of people got this one correct. So I think this one's definitely worthwhile looking at. So look at this. If I was doing this question, I might even set it up and kind of go, well, what have I been given here? Well, clearly I've been given this, 0.25 moles. Well, moles is always little n. Little n is 0.25 mole, okay? I've also been given 175 milliliters, which is a volume of 175 milliliters. Okay, and it says, what is the molar concentration? Well, molar concentration is C. It's capital C. And the formula for molar concentration, C is equal to little n over V. Okay, and that's right off my hub, but maybe you might have had that on an equation sheet that you were using. Okay, so now I've got to substitute and solve. Now there's one little tiny thing here, is that the volume has to be in liters, because look at this. In each case here, they're giving you the answer in moles per liter. Now one of them gives you in grams per mole, but we clearly know that's not correct. And so it's one of these moles per liter. But so here, before we're going to have to go 0.25 moles and 175 milliliters. Well, to convert that to liters, you got to divide by 1,000, so that's 0.175 liters. So divide that by 0.175 liters, and now you get out your calculator and you go 0.25 divided by 0.175, and I get 1.428 1.42857. But look, there's only two significant digits allowed, so it's just 1.4. So the correct answer is B, 1.4 moles per liter. Okay, so that was that's number 2. Okay, number 3. It says, what is the mass volume percent, or the MV percent, for a solution made with 7.5 grams of copper, 2 chloride, and 125 milliliters of water? Well, 87% of the people got that correct. And so for this one, the formula, the mass volume percent, is the mass of solute divided by the volume of solution, and this is in milliliters and this is in grams. So this one is milliliters. You don't use liters for that one, but then you multiply by 100. So here we go. It's going to be 7.5 grams divided by 125 milliliters times 100. That's the mass volume percent. And I just showed you here. Here it is in the note where we did an example of this, and I use grams and milliliters. So sure enough, let me get my calculator out and go 7.5 divided by 125, and then I get 0.06 times 100, and I get 6%. Okay, so it's that one right there, 6%. Okay, what volume of a 6 mole per liter hydrochloric acid solution is needed to make 500 milliliters of a 0.15 mole per liter solution? Well, this is a dilution question where you're taking something that is very concentrated and you're diluting it down to something that's less concentrated. So here it was in the notes. I took you guys through some different dilutions, and there's the formula. C1V1 is equal to C2V2. So here we go. Well, here I'll do the givens again for this one. So given, it says 6 mole per liter, so that's a concentration. So C is equal to 6.0 moles per liter. And I know that's a C1 because it's a concentrated value compared to the other one. The other one, I can tell you, the C2 is 0.15 moles per liter. So that's not very concentrated at all. It's very dilute. And then V2, that's how much of the dilute solution we're making, is 500 milliliters. And my required is the V1. So how much of that 6 mole per liter solution do I need? Okay. Analysis, I go C1 V1 is equal to C2 V2. And let's sub and solve. Now in this case, we can keep it as milliliters, but then my answer will be in milliliters. So watch this. I'm going to sub in my 6 moles per liter into the C1 times V1 is equal to 0.15 moles per liter times 500. And because I'm in milliliters, my answer will be in milliliters. So I divide by 6. And so the answer here should be in milliliters. Okay, so 0.15 times 500 is equal to 75 divided by 6, and I get 12.5 milliliters. Now I look over at my solutions here, and I go, well, I don't see that solution because it's not this one, it's not this one, it's not this one. But wait a second, this one's in liters. So let me take that 12.5 and divide it by 1,000. And I get, oh, that's 0.0125 liters. There it is. So that's the one. There's a little trick in the solution to that one. Okay. Number 5, it says alcohol dissolved in water is an example of a blank. What type of solution? Well, here was the note. We did a few different examples of, solid into a liquid into a liquid. And sure enough, the example I gave was alcohol into water was an example of a liquid into a liquid. So this one is B, and 93% of you got that one right. Okay, number 6. What effect will increasing the temperature have on the amount of gas that can dissolve in a liquid? Okay, well, that was in that third lesson. One of the questions we asked in that third lesson is, what determines how much of a substance will dissolve? Well, we knew that temperature impacts it. Now, if you're talking about a solid into a liquid, an increase in temperature will increase the solubility. But if you're talking about a gas into a liquid, which is what we're talking about here, it's a gas into a liquid, if you increase the temperature, you'll decrease the solubility. So what effect will increasing the temperature have on the amount of gas? It will reduce the amount that can dissolve. It will reduce the amount that can dissolve. If you increase the temperature, what impact will it have on the amount of gas that can dissolve? It'll reduce the amount that can dissolve. And so that was basically this right here. Okay. What is the following piece of lab equipment called? Well, 100% of you got this correct. And so, sure enough, that was from the one where we were talking about preparing solutions, and we talked about volumetric flasks. And sure enough, there it is. It's a volumetric flask. It's a round-bottomed flask. All right. This one, only 47% got it correct, so let's spend some time on this. It says, calculate the molar concentration. So here we go. Given, required. Calculate the molar concentration. So molar concentration is capital C is the question mark of 1.2 liters of solution. So we've been given a volume is 1.20 liters containing 122.5 grams. So the mass is 122.5 grams of potassium chlorate. Okay, well, that's K for potassium, and then chlorate is ClO3, and I'll double check I flip my periodic table over, and ClO3 is a -1 charge, and potassium is a +1 charge, so I don't need any subscripts. Okay, so potassium chlorate. And here we go. So what they want is C. Well, I know C is equal to N over V, so I've got the V, but I don't have the number of moles. And so the first thing I'm going to have to do is I'm going to have to calculate the number of moles, which is the sample mass divided by the molar mass. Okay, so I've got the sample mass of 122.5 grams. And now I'm going to have to go to my periodic table and look up the molar mass of KClO3. Well, here we go. The molar mass of potassium is 39.1 plus chlorine is 35.45 plus 3 times 16. So let's do that. 39.1 plus 35.45 plus 3 times 16. Oh, that's interesting. It's 122.5. And so look, this becomes 122.5. And guess what? That's in grams per mole. Well, it means I have basically, I know it's not exactly, it's a little bit, but it's basically 1 mole. And then I come over here then, and I substitute in C is equal to 1 divided by 1.2. That's the number of moles, and that's the number of liters. So 1 divided by 1.2 is 0.833 repeater moles per liter. So it's it's 0.833. It's that first one. Okay. Next question. It says, calculate the mass in grams of calcium chloride that is needed to make. So it's just a rearrangement of that last one. 73% of you got this right. So here we go. It says, calculate the mass. So the required is the sample mass needed. So hopefully a lot of you are eliminating that one right off the bat, because that's not a mass, that's a count, that's a mole. Okay, now we've been given that we've got a volume of 725 milliliters. And I see right away that they gave me a liters here. So I'm going to convert this to liters. I'm going to divide by 1,000, so it's 0.725 liters. And I've got a concentration of 0.35 moles per liter. Okay, so this is going to be another one of these double equation ones. So I'm going to have to go, first of all, I know I want to get to M is equal to the number of moles times the molar mass. So I'm going to have to get the number of moles by going N is equal to C times V, which is just a rearrangement of the concentration formula. Okay, well, let's sub and solve into that. So N is equal to 0.35, which is the concentration, times the volume, times 0.725. So here we go, 0.35 times 0.725, and I get 0.25375 moles. And then I'd come over here and go, well, that's the mass is going to be 0.25375 times, oh, I need the molar mass of calcium chloride. So the molar mass, and it's calcium, that's Ca plus 2, chlorine's minus 1. Oh, so it's CaCl2. I have to crisscross. And Ca is 40.08. There's one of them. Plus 2 times 35.45, 40.08 plus 2 times 35.45. So that is 110.98. So 110.98 goes right there, times 0.25375, and I get 28.1, but I think I only had 2 significant digits. Yeah, 0.35, so it's 28 grams. So it's B for that one. Okay, and I just showed you here, we did some examples of that in our notes. Okay, let's keep going. Number 10. Which statement about water is not true? Now, 80% of you got this right. Now, this came from the note where we were talking about whether or not things will dissolve or not. And we talked about the nature of the solute and the solvent. And what we said here was like dissolves like. So a polar solute will dissolve in a polar solvent. And the example I gave was water, which I showed you here was very polar, and sodium chloride, which is table salt, which is also very polar. And we know that salt dissolves well in water. Polar dissolves polar. So let's go back up. So it is made up of a polar molecule, true. So that's not the answer, because it says which is not true. It dissolves most non-polar compounds. Ooh, that's not sounding good, but it dissolves most polar compounds. That is true. It dissolves most ionic compounds. Well, ionic compounds are polar, so that's true. So it's this one. It's B. It dissolves most non-polar compounds. It does not do that. It dissolves polar things, because like dissolves like. Okay, this one was matching definitions. I showed you here, we had miscible here, we had solubility here. Later on, we put in the definition for dilute. So here we go. A liquid that can be combined in any proportion is miscible. So that's number 4. A qualitative description of the concentration. So if it's qualitative, it uses words. So that's dilute. So dilute is a qualitative description. Whereas it says a quantitative description, that would be the molar concentration. And then the amount of solute that dissolves in a given quantity of solvent is called the solubility. Okay, so those are some definitions. Here was the next one. 33% got this one right. So there's clearly some little concerns here. So it says 2 samples of the same solution can contain different relative amounts of substances that make up the solution. So I can see why this one maybe led to some difficulties, but I want to emphasize something here. So first of all, it says of the same solution. In other words, you create a solution. Okay, so you mix some solute in and it all dissolves. So what they're saying is that if you take a sample from here of that solution and another sample from here, can those 2 samples contain different relative amounts of the substances? No, they can't. Once everything is dissolved, if you took a sample from here and if you took a sample from here, they would be identical. They're identical. That's what makes this a solution. Okay, they're identical. So this one is false. Now let me show you in the notes. Look right here. I gave you the definition of a solution, which I called a homogeneous mixture. But then I said 2 samples of a solution contain the same substances in the same relative amounts. Now, I think where some of you got confused is I said there is also this other characteristic called variable composition. But all that means is that you can mix things up with different ratios. So you don't always have to put in like 1 gram. You could put in half a gram or a quarter of a gram and make up different solutions. But once you'd mixed up your solutions, every one of the solutions would have the same relative amounts of the different components. Okay, so there's a slight difference there between those. I know that one was a little bit tough. But 2 samples of the same solution, no, they cannot contain different relative amounts. If you have the same solution, every sample will have the identical amounts of each solute. Okay, this one, 93% of you got it right. So it says, when you add calcium carbonate to water, will it dissolve? Well, this one, you used your solubility guidelines. So you would flip your solubility guideline over. I wanted you to go find carbonate, which is CO3 -2, and there it is right there. And you would then check and see, well, where does calcium fall? Well, calcium is not in group 1 and it's not NH4, so calcium falls down here, so it's low solubility. So it says, when you add calcium carbonate to water, will it dissolve? False. I guess it should have said no. No, it won't dissolve. It will not. When you it will dissolve. No, it won't dissolve. False. Okay. No chemical reaction occurs when solutes dissolve in solvents. 73%. You guys, anytime something dissolves in a solvent, it is not a chemical reaction. So it says no chemical reaction occurs. That is true. There is not a chemical reaction. You could get your solute back by evaporating off the solvent, by evaporating the water. So when a solute dissolves in a solvent, no chemical reaction occurs. You can separate them by physical means. Okay. Which factor does not affect whether or not a solvent will dissolve? Not, I gave you a hint here. It's not how fast it will dissolve. Okay, so I want to know which of these factors has an impact on whether it will dissolve at all in the solvent. Well, this came from the note here where it says, what determines whether or not a substance will dissolve? Well, it's the nature of the solute and solvent. In other words, whether they're polar or non-polar. the ion or molecule size, and the ion charge. So those are the three things that impact. So clearly the one that doesn't impact is surface area. Now I think that confused some of you, because surface area does impact the rate or the speed at which something dissolves. In other words, the greater the surface area, the faster something dissolves. But remember that that's not whether or not it will dissolve at all. So, you know, if you have a cube of sugar versus a teaspoon, the teaspoon will dissolve faster because it's a greater surface area, but ultimately both of them will dissolve. Okay, so that was a bit of a trick one. Okay, there we go. So that was the quiz. That's about 25 minutes. So hopefully that helps you guys, but please let me know if you have any questions.